is Dr. Juliet. Welcome again to Joe's Summit Biochemistry Hall. Today, to take us forward in our biochemistry tutorials, we should be looking at enzyme kinetics, specifically how to derive the Michaelis-Menten equation. This equation is based on certain assumptions. Number one, it is based on the fact that we assume that the reaction is in its initial state, where the concentration of product is almost negligible. The second assumption for this equation is that the substrate concentration is far greater than the product concentration, so almost the same as the assumption 1. The third assumption is that the system is in a steady state, so that the concentration of the enzyme substrate complex is constant. And then lastly, another assumption here is that the enzyme concentration is far less than the substrate concentration. Now, how do we derive the Michaelis-Menten equation? We start from the beginning because it's based on the initial state of every enzyme catalyzed reaction. Where we have enzyme plus substrate should give us the enzyme substrate complex before we begin to form the products to give us the E plus the product. Now, the K1 is the constant for formation of ES, K3 formation of product, K2 breakdown of enzyme substrate complex, and K4 the constant for the breakdown or the reformation of enzyme substrate from enzyme and product. Now, the first assumption we're going to be employing to derive this equation is the assumption of steady state. If we are saying that the enzyme substrate concentration is constant, it means that the rate of formation of this ES complex must be equal to the rate of breakdown of the ES complex. In that case, if we're going to mathematically write what I just said, we're going to be doing this K1 ES, which is the formation of the ES, and also K4 EP, formation of ES. If you add two of them, it should give us the breakdown of ES, which is K3 and K2. So we see it here, K2 ES, K3 ES. So this is for breakdown and this is for formation. You're going to write the equation based on where the arrows are coming from. K1 will be ES, K3 will be just this, K2 you write it with this, K4 you write it with this. So we have this equation. And since also from assumption 1, we're saying the reaction is at initial state, so product concentration is almost 0. So if we put 0 here, this will be eliminated. So we have only just this from this equation 1 on the left hand side. And on the right hand side, everything remains the same. If we take these two common things here, ES is common to two of them, so we'll bring out ES as factorization, and we'll put K1 and K2 in brackets. So once we assume the product is 0, equation 1 from here becomes equation 2. This part is knocked out because P is assumed to be 0, so we have only this part. And then we factorize, since ES is common to both of this, we have this equation 2. If we rearrange this to have the constant on one side, we're going to have K2 plus K3 over K1. If we rearrange equation 2, we're going to arrive here. K2 plus K3 over K1 is equal to this. And then this is what we call the Michaelis-Menten. This is what we call the Km. Michaelis-Menten constant. Michaelis-Menten constant, Km. K2 plus K3 over K1 is what we call Km, which later I'll be explaining the significance of Km. Km is simply the concentration of the substrate at half maximum velocity. We'll see that in the graph. Now, Km is this. This is not Michaelis-Menten equation. We'll just arrive at Michaelis-Menten constant. Now, going further from this step 3, we'll remember that total enzyme in the system is free enzyme plus the enzyme substrate complex. So we have this. So if we make free enzyme subject to the formula, we arrive at equation 4 from equation 3. Now, equation 3 is on its own. From this equation, if we make E subject, we arrive at this. Now, if we carry this equation 4 and put in equation 3, substitute. Wherever we have E1, we put ET plus ES. So we have this ET minus ES, sorry. So here we have ET, E, we now have ET minus ES. S is still there over ES. And remember, this is Km here, Km here. So Km, if ES is dividing everything here. So ES divides this, ES divides this. The S is still out there. And because this cancels this out, is equals to 1. So Km is ET over ES minus 1, bracket, substrate, concentration, equation 5.